Okay, welcome back to more tutorials on stoichiometry. And we are jumping in today. We've already done this example in class, so I'm going to leave this one for now. If you have questions about it, of course, you can ask me, but I figured I'd go over a few of the others that you might have questions about. So our next question asks us to determine the mass of carbon dioxide produced when 0.85 grams of butane react with oxygen according to the following equation. So even if we're not sure what butane is, that is our given. And it tells us that we have 0.85 grams of butane and that those are reacting with oxygen. So if they're reacting with oxygen, the only thing that's reacting with oxygen in this equation is this C4H10. So that must be butane. And then we're asked to find the mass of carbon dioxide. So mass of carbon dioxide. So I've identified my given, I've identified my unknown. I haven't yet balanced my chemical equation. So let's jump into balancing this chemical equation. And like many combustion reactions, this one's a little bit of a hassle to balance because the first thing we want to do is put a 4 here so that we have 4 carbons to balance our 4 carbons on the reactant side. And we would put a 5 here so that we have 10 hydrogens to balance our 10 hydrogens on the reactant side. Unfortunately, that means that I need 8 plus 5, so I need 13 oxygens. And I can't get 13 oxygens because I have that 2 there. But if I were to multiply 2 by 13 over 2, that would give me 13. So what I'm going to do is put that 13 over 2 there as my little mental reminder and recognize that I need to multiply this whole equation by 2. So I'm going to put a 2 here. I'm going to put a 13 here. I'm going to put an 8 here, and I'm going to put a 10 here. So now we have 8 carbons on the reactant side because I have 2 times 4. I have 8 carbons on the product side. I have 20 hydrogens on the reactant side. I have 10 times 2 for 20 hydrogens on the product side. And then I have 26 oxygens, and I have 16 plus 10 for 26. So we've now balanced our chemical equation, and we're going to start with the given. So we're going to start with 0.85 grams of butane, the C4H10. And we know that step two was to identify our given and our unknown. We did that even before we did step 1. And step 3 is to change the given into moles. So because I have grams, I know that I need to convert from grams to moles. And so I'm going to do 4 times the mass of carbon, which is 12.11, and 10 times the mass of hydrogen, which is 1.01. And I'm going to come up with a mass of 58.1, let's see, 2 grams of C4H10 per 1 mole of C4H10. So now my grams of C4H10 have canceled out. And my next step is to change moles of given into moles of unknown using the coefficients from my balanced chemical equation. So I know I want C4H10 on the bottom because it's currently on the top. So I look at my balanced chemical equation, 2 moles of butane. And I want to change to carbon dioxide. So I look at my balanced chemical equation, 8 moles of carbon dioxide. And now the moles of butane on the top, moles of butane on the bottom, those 2 are going to cancel out. And now that I have moles of carbon dioxide, I'm asked to find mass of carbon dioxide. So I know I need to find the molar mass of carbon dioxide in order to change from moles of carbon dioxide to mass of carbon dioxide. So again, 12.11 plus 16.00, 12.01, sorry, 16.00 times 2, and we have 44.01 grams of CO2, and we can cross out moles, and we have 0.85 times 8 times 44.01 divided by parentheses 58.12 times 2. And when we plug all of that into our calculator and take into account that we only have 2 significant figures, we get 0.78 grams of carbon dioxide. So that's how we solve that one. All right, our next question asks us to determine the mass of antimony. So there's my unknown mass of antimony produced when 0.46 grams of antimony 3 oxide, so 0.46 grams of antimony 3 oxide react with carbon according to the following equation. So we need to balance our equation, that's step 1. So I have 2 antimony, I've started to balance this one for you, and 2 antimony. I have 3 oxygens and 3 oxygens, but I have only 1 carbon here and 3 carbon there. So I'm going to put a 3 in front of carbon to balance my chemical equation. So I've balanced my chemical equation. I've identified my unknown and my given. I'm going to start with what's given. So that's the 0.46 grams of antimony 3 oxide. And I'm going to change the given into moles. So I'm going to look up the mass of antimony, which is 121.76. But I have 2 of them, plus 3 times the mass of oxygen, which is 16.00. And we get that the mass of antimony is 291.5 grams of antimony 3 oxide for every 1 mole of antimony 3 oxide. Okay, so we've converted from grams of antimony 3 oxide to moles of antimony 3 oxide. So our next step is to use our molar ratio to convert from moles of antimony 3 oxide to moles of antimony. So I look at my balanced chemical equation. For every 1 mole of antimony 3 oxide, I have 2 moles of antimony. And I've converted to moles of antimony. I can see that grams of antimony 3 oxide have canceled out, moles of antimony 3 oxide canceled out, and now I'm just trying to convert to mass. So I'm going to need to use molar mass. So 1 mole of antimony has a mass of 121.76 grams. And so I'm going to multiply across the top and divide by the bottom. And when we do all of that, we get 0.38 grams of antimony. So same process each time. So for question 4, it asks me what mass of sodium chloride is produced. So there's my unknown mass of sodium chloride when chlorine reacts with 0.29 grams of sodium iodide. So 0.29 grams of sodium iodide is my given. And it tells me this is a single displacement reaction. So I have to write the reaction and I have to balance the equation before I can start a stoichiometry problem. So I'm told that chlorine, and I know that's diatomic, reacts with, so I know that's a plus, sodium iodide, Na. Sodium's a +1, iodine's a -1, so that's all set to yield. Well, it tells me it's a single displacement reaction. It also tells me it's going to make sodium chloride, so I know I'm going to have sodium chloride, and what's left over is the iodine. But iodine, like chlorine, is diatomic, so I'm always going to put a little 2 there. So I have 2 iodines, I'm going to put a 2 in front of NaI. I have 2 chlorines, I'm going to put a 2 in front of NaCl. I have 2 sodium and 2 sodium, and we're balanced. So our next step is we've balanced our chemical equation, we've identified the given and the unknown, and we're going to start with what's given. So we're going to start with 0.29 grams of sodium iodide. And as before, I'm trying to go from grams to moles. I'm going to turn to my periodic table. I'm going to add up the mass of sodium and the mass of iodide. And I'm going to find that the mass of sodium iodide is 149.89 grams of sodium iodide in 1 mole of sodium iodide. Now my grams of sodium iodide have canceled out, and I need to do my next step, which is to convert from moles of given to moles of unknown using my balanced chemical equation. So in my balanced chemical equation, there are 2 moles of sodium iodide, and I'm trying to convert to sodium chloride, and there are 2 moles of sodium chloride. So I'm going to put 2 moles of sodium chloride on the top. And then I'm being asked to find mass. So I'm going to convert moles of sodium chloride to grams. So I need molar mass. So for every 1 mole of sodium chloride, there are 22.99 plus 35.45 is 58.44 grams of NaCl. And now I can see that moles of sodium iodide's on the top and the bottom. That cancels out. Moles of sodium chloride's on the top and the bottom. That cancels out. And I find that I have 0.11 grams of NaCl. Okay, last problem. This one asks me what mass of hydrogen peroxide, so mass of hydrogen peroxide is my unknown, must decompose to produce 0.77 grams of water. And this is a case where we're given the product and asked to find the reactant. And we have to remember that it doesn't matter whether we start with product or reactant, the process is the same. So I know that I need to write a balanced chemical equation. So I have hydrogen peroxide decomposing, and I know it produces water. So this requires you to think a little bit. If you've ever poured hydrogen peroxide on a cut, you know that when you pour hydrogen peroxide on a cut, it bubbles. So we know that it produces a gas. So the gas that it produces is oxygen. Now, we've got our equation written, but it's not balanced. So I have an even number of oxygens on this side and an odd number on this side. So the first thing I'm going to do is try and fix the odd even problem. So I'm going to do that by multiplying the odd number by 2. And when I do that, I get 2 oxygens plus 2 oxygens. So I have 4 oxygens. So I'm going to come back to this side and put a 2 in front of hydrogen peroxide. That gives me 4 oxygens. It also gives me 4 hydrogens. So I'm going to take a look, and I have 2 times 2. So that's 4 hydrogens. So we're all set on balancing our chemical equation. So last step is going to be, not last step, next step is going to be to start with our given, which is 0.77 grams of water. And as always, we're going to convert from the unit that we're given to moles. And since we're given grams, we know we're going to need to use molar mass. So I'm going to look up the mass of hydrogen and the mass of oxygen, and I'm going to add them up to get 18.02 grams of water in every 1 mole of water. And as always, I'm putting the mole on the grams on the bottom because I'm starting with grams and moles on the top. So now I need to convert from moles of given to moles of unknown. I look at my balanced chemical equation and I see I want to put moles of water on the bottom. So 2 moles of water for every 2 moles of hydrogen peroxide. And now our last step is to convert from moles of unknown to grams of unknown, because I'm asked to find mass. So one more time, I need molar mass. So I have 1 mole of hydrogen peroxide on the bottom, and I have 2 times the mass of hydrogen, which is 1.01, plus 2 times the mass of oxygen, which is 16.00, and we get 34.02 grams of hydrogen peroxide for every 1 mole. Let's double check that we have everything where it needs to be. I have grams of water on the top, grams of water on the bottom, so I can cancel them out. I have moles of water on the top, moles of water on the bottom, I can cancel them out. I have moles of hydrogen peroxide on the top and moles of hydrogen peroxide on the bottom, I can cancel them out. And so the unit that I'm left with is grams of hydrogen peroxide. We multiply across the top, divide by the bottom, and we get I have only 2 significant figures, 5 grams of hydrogen peroxide. So I hope that's helpful. As always, if you have questions, I look forward to seeing you in class, and I will be happy to answer them then.